Hello all, let us talk about a few points which we tend to talk when we work on embedded systems, and these also determine the performance of the embedded system. So these specific points are very important in any embedded system used across any domain. The first thing that we wanted to talk here is the processing capability of an embedded system. So what is this processing capability? So example, let us assume I have a board where there are number of connections that are coming to it. Example, a ECU kind of scenario where we have multiple boards that are connected to this board, and we get number of requests from it. So these all requests must be handled by this particular system, and the output of this should be passed on to some other system. So here the multiple processing capability of the embedded system plays a critical role. There are several other scenarios where based on this processing capability we use the different chips from different manufacturers. Example, if we take the case of a microcontroller, we use it for some low-end applications. If we go to the processor or FPGA, we use them for a high-end applications. So the processing capability of these particular systems, even if we talk about a microcontroller and a low-end application, still the processes that are handled by that particular microcontroller within the scope of its performance is important there. So this is one of the critical parameter, and the entire performance of this system depends on the processing capability of that particular chip that is embedded on this board. And the other thing, error handling. So this is where most of the embedded engineers do falter. So if example, we have a system where it works perfectly well and meets all the specifications which are given to the programmer, and let us assume he delivered the board which meets each and every specification that is provided. So while specifications are a bible to embedded system, or basically when we say specifications, the requirements of the product are a bible to embedded engineer, there are number of threads behind these requirements where the engineer has to implement in the system. For example, if we say a simple power supply on the board should produce 3.3 volts from 5 volts. Okay, so along with this, along with producing 5 to 3.3, it also should handle the temperature scenarios. It also should handle over voltage scenarios, output short circuit scenarios. So this is, while this is from the hardware front, from the software side, if there is a channel between two ICs which are talking to each other, example AI to C, SPI, UART, whatever. So during this scenario, if there is a error data that is received from one of the device, it should be handled properly. So this is very important. While some of these could be part of the requirements, many of these are not mentioned, and it is the responsibility on the part of the embedded engineer to handle these in their system. The next thing is testability. So what we mean by testability here is in an embedded system, as per the requirements when we design this board, this particular system should be testable. So testable meant, example, if I have a complete board in hand, I should have means to test this board. The means could be like having an LED on the board, or writing a small scripts which diagnoses the entire board and gives a output, like example we call power on checks. So all these should be included, and along with that, generally when we design these boards during the prototyping, these may not be of that much importance, but when we go to the manufacturing, and also once the manufacturing is completed, one is goes to field, these play a critical role, because during the prototyping the engineer sits on the test bench, works on it for days to bring up that board, and he knows in and out of it. But once it goes to manufacturing in bulk, basically the production activity, production guys are not completely aware of this particular system, so they should have some means to identify what is happening in the system once it in the board, once it is programmed and powered up. And then definitely in the field, once the field engineer goes, even though he knows something, but the first hand diagnostics, if they are provided instantly, it would help him to identify the problem easily. So testability is one of the important aspect where some people call it the debugging, where you need to know the various means, you need to have the various means to perform the debugging on your board. And the second and another important thing is memory availability. While we talked about different scenarios like microcontrollers, SOCs, or processors, FPGAs, the basic thing of all these, basic need of all these is that they should have some memory where we can program that memory and operate that microcontroller as per our requirement. So when we say program that microcontroller, we need some memory where we need to store this program which we have written, and then it need to run without any constraints. So that means it should the system should have enough memory so that this can work based on need. Along with the program memory, there should be, in some cases there should be data memory, where like data memory could be needed for everything, but specifically in some cases the requirement could be where you need to receive data from external field and store it into the memory, like saving into an SD card kind of scenarios. That's what we mean here. So in these scenarios, you should have enough memory so that you keep the records that are received, and also the system should function seamlessly, and it should not happen that system fails because of unavailability of required memory. And the timeout scenarios. So this is another important scenario where let us assume I have a board A which is expecting a message from a particular external sensor or something, and then we read this data, and let us assume there is one more board where it has to pass on information and receive the acknowledgement. So microcontroller A, microcontroller B. So when these two boards A and B communicate with each other, there should be a specific timeout that is fixed for this communication. When we say specific timeout, it meant let us assume a microcontroller sends a data and it should not wait forever for response. So there should be a fixed timeout, and then again the microcontroller should send a command. There is every chance that the message should be could be erroneous in some cases, which are unintended cases, or the message might not be interpreted properly. So in all these scenarios, there should be definitely in some scenarios there will be acknowledgement that it has been received. In case if the acknowledgement is not received, or intended operation is not performed, or the microcontroller which is receiving the data has not received the data for a specific time, then it has to request for data, or it has to initiate the data as per the requirement. So timeout, important thing. And then the reliability. So, embedded systems, the entire operation is very critical in many applications. So example, if you take some commercial applications, the functionality of this particular embedded board may not be that critical, but there are critical applications like the medical, the aerospace, the military kind of applications, where the reliability of embedded system is very important. It should work seamlessly without any issues. Definitely embedded system works without human intervention, right? Even though for some systems we have displays, which we call it human machine interface displays, HMI displays, many systems work independently and operate and give output based on the internal processing that happens using all the algorithms. So it should be as reliable as possible. So the points which we have discussed previously, all the points hold good here, and all these should contribute, and none of these should fail, such that the system remains reliable and it is operational in the field forever, in all the critical applications that we are talking. So there are several scenarios, and the last important scenarios, while we have designed an operating system with all these scenarios in mind, we might not have imagined few scenarios, or we might not have taken care of them during design, such that only at a later point of time we get to know. So some of these we get to know that there is a problem. So some of these scenarios specifically are the operating conditions, like example the temperature, humidity, and then the vibration, any drop test, example the EMI/MC scenarios. All these scenarios should be are generally part of these EMI/MC specifications that are defined, the qualification tests that are defined for this product. So to meet these specifications, the product should be designed from the beginning itself, because only when the embedded board is available, then only we can perform all these qualification tests. So it is important that during the design stage itself, all these points are kept in mind and interpreted properly, such that it doesn't fail in the qualification test. So qualification test, as we mentioned, could be temperature test, could be temperature wise operating and storage, could be humidity, could be like some like salt spray kind of things, or could be vibration thing, as we mentioned, radiated emission, conducted emission. All these play. See, finally the embedded system these days, our environment is completely filled with noisy things, right? We have number of communication mechanisms around us, number of electronics products around us operating at various frequencies. Every product is not a genuine product, right? Some could be junk products, where when we say junk products, could be clones of something, where you get radiation out of this, and this could disturb the actual system environment. So considering those scenarios, during the requirement specification itself, there will be specifically the environmental specs shall be defined, the EMI/MC specification shall be defined for which this system has to qualify. So based on the environment it is used, and this particular qualifications play a major role in which kind of markets these specific embedded systems shall be used. So very important specifications, and the embedded system specifically need to be tested and shall be tested in order for this product to be used in these different markets, like example European market, or the US market example. So and then there are several complaints that are available for different countries which need to be taken care. So overall, all these factors play an important role to come up with an embedded system which is operational and which can be used across the which can be used in the fields without any issues. Hope this helped to give you a glimpse of a overall high level requirements which are very important from the embedded board perspective. In depth when we go, there are several other things, but very high level, these are the things which the designers need to keep in mind, and these need to be taken especially during the initial design stage itself, such that at the end we come up with a product which can be used without any issues and which passes all the required compliance. Please let us know if you have any questions. Please post your comments, please post your thoughts. Please like and subscribe our channel. Thank you.